Hello, everybody, and thanks, Meister, for introduction. So today's topic is moving from documents to models, and I will share with you some experience which I gained working with many organizations which are trying to do exactly that, to change their engineering practices and switch from documents to model-based practices. At Magic, we kind of see this as a natural evolution of how we human exchange information. So initially, I think we started with drawing some pictures, because as you may know, the picture is worth 1,000 words. But later we wanted to capture this information somehow in a more uniform way. So we invented some text, some languages written languages to describe this information. And these languages have been applied in many places around the world. We tried to describe various information and put it on papers. Later, we invented some technology how to produce this paper faster. And this actually ended up maybe with a lot of trouble, also maintaining all this information in those papers and being difficult to synchronize, to keep it up to date, and so on. So we kind of coming back to where we started. So we want to have some visual ways to communicate information, but we also want these pictures to be unambiguous, so that we have a standard language and we able to communicate, and we have better ways to keep it in sync with the current changes and preserve knowledge in that form. But still, the state of the practice in systems engineering today is that documents are the main way how we exchange information, how we capture it, and this approach kind of works. But according to research, we can find that statistically 55% of highest level defects and issues in system engineering are made in requirements analysis and design phases, and they make it to very late phases of system engineering, and this cost a lot. So we want to challenge that, and model-based systems engineering is really a new way which is promoted by INCOSE, International Council on System Engineering. Model-based system engineering is about driving systems engineering activities by modeling and as an activity, and by models as a knowledge, as a form to store and exchange knowledge. So this is a slide which was I think prepared and presented now quite a few years ago, back in 2008, and it was I think developed together in collaboration between Object Management Group, the body which standardizes modeling language, and INCOSE, International Council of Systems Engineering. And in this slide we see that systems engineering practices, which in this slide they say this is past. I think this is still maybe what we have today in many organizations. We have various documents which describe specify systems, define interface requirements, provide some understanding of the system design, maybe try to also do some analysis and trade-off, capture test plans. And the future, as seen by INCOSE and by OMG as well, is that in the future we will try to capture this information more in the models. So we're trying to move from document-centric to model-centric practices. However, this is not easy transition, and we will talk about that. But some people also have some misunderstanding that models are the same as drawings. So this is not exactly the same, because in modeling world, what we do, we try to have a model repository which has different model elements. And you can have multiple views, different views presenting them, and you can reuse those elements in those different views. But they are based on the consistent set of model repository. Whereas in drawings, you maybe have some pictures, but they are kind of hard copies, right? So they're done separately, and typically these are very difficult to integrate and reuse some knowledge. So what we try to do, we try to use models really to have those different views and actually generate documents if needed for specific stakeholders to provide specific views to the system according to a viewpoint that has a particular role or a particular stakeholder to the system. But it is different from drawings, which are hard copies, and you can have text, you can have document with drawings, but they are very difficult to maintain and keep up to date, and they are not able to provide a consistent information in one place. So when organizations try to adopt model-based system engineering, I think most of organizations quite clearly conceive what is the potential value from models and modeling. So they try to do apply model-based system engineering in order to manage complexity, first of all, because systems today becoming more and more complex, and we have to deal with complexity, to have to apply abstraction, to make to simplify the system and emphasize the most important aspects, and maybe separate the specification from design so that you can experiment with multiple variants of the system design and so on. You want to improve quality because as opposed to informal drawings or text models are maybe not always fully formal, but they at least are semi-formal, and they provide you better foundation for analysis, and this enables better quality. And it also improves communication because it is well known that visual information is typically better conceived and easier to understand and analyze. And it is very easy to hide some issues in design in textual description. Whereas if you have a diagram, for example, state machine with a state which is a deadlock state, it is clearly seen that there is no transition out of it. So diagrams are typically a superior way to communicate, and because you reuse it, then you have also better quality and more consistency. And also the organizations see models as an enabler for a closer collaboration in cross-functional teams. Many problems actually lie in difficulties for different functional teams to work together. For example, software people collaborate with hardware people, or maybe system analyst or system engineer focusing on requirements requirements engineer collaborating with verification and validation engineers who try to develop test cases and try to plan for testing the system when it is built. And organizations also see that as a potential for preserving knowledge, since many of organizations suffer from doing many similar things over and over again, and then they need to do the same things again, and they cannot really digest information from those documents and various type of knowledge artifacts which came from the previous projects. So knowledge preservation is something which is on agenda in many organizations, but it is not an easy thing to achieve, I would say. From our practice, I think many organizations can achieve many of the benefits which are mentioned above by just using temporary models, which we call them throwaway models, so they are useful for some time, but then you don't try to keep them up to date. But in many organizations, knowledge preservation is very important. For example, in some organizations working in defense domain, you have to face the challenge that you develop systems like, for example, a missile or some other large system, or maybe it is in use for 50 or 60 years. So you have to maintain it over that time with maybe some small changes and some small enhancements. But this life cycle is actually larger, spans larger than typical career of a system engineer or software engineer. So you come to a situation where you don't really have people who know the system from A to Z. And you have to rely on some written knowledge, and the documents typically do not provide a consistent set of information. So, and organizations, of course, if they can preserve knowledge, then they are looking into reusing this, especially in problems like product line engineering. You would like to reuse a lot of work in each new project. But in order to achieve this value, you really have to have a working modeling solution deployed in the organization. And in order to have this modeling solution, you really need to combine three things. You need to have a modeling language, which provides you the basis for communication. Then you need to have a methodology, which tells you which diagrams you should start with, which things you should do afterwards, how you refine model elements, how you maintain them, how you structure the models so that you can find them, and then also a modeling tool which enables preserving and reusing this knowledge, and also enables maybe automating certain things, like, for example, producing documents that satisfy certain viewpoints from modeling repository. And those three things together, language, methodology, and tool, they should provide a productive infrastructure for applying model-driven development or model-based system engineering, whatever you call it, in the context of a particular organization. So here the context is very important, because depending on the previous practices and the currently available tools which are used in engineering processes, it might be easier or more difficult to get started with modeling. And you should really plan very carefully how you start, how you evolve, which roles you involve in initial phases of the project, how you spread model-based system engineering practice in organization, etc. And let's get started by taking a closer look into first of those three elements which you have to do. So let's discuss about language. And currently for the model-based system engineering, everybody, I think, or most people at least, would really agree that systems modeling language, SysML, which is a standard modeling standard from OMG, Object Management Group, is probably considered as de facto standard for graphical modeling in system engineering. And it's used for various purposes. You can specify systems, you can design systems, you can do some analysis, you can use it for verifying certain things, and maybe also planning validations of the system. And it's a kind of large language which includes nine diagram types, 9 standard ones, and you can also create your custom extensions and also custom diagrams types. And it is dedicated for modeling complex systems that include hardware, software, information, staff, procedures, facilities, maybe other resources, etc. And it is a rather large language. It is built on the top of UML, which is also a fairly large and complex language. And it uses not the full set of UML capabilities, but it also adds certain things which are not included in UML. For example, requirements or parametric models. So these are the things which are not covered directly in UML too, but they are included in SysML to support systems engineering practices. And some people really say that the SysML language is very complex. You have to learn a lot. And some people complain that this is not perfect. But I would like to say that I believe that English is also not a perfect language, but we use it for communication because it's de facto standard, and we probably don't need to learn full set of English words, which you may find. I think you may find something like 500,000 of English words in largest dictionaries. No, you need to learn just those few thousands which you need for basic communication, and maybe then also some terminology which you use in your business domain, in addition to this basic subset. So the same with SysML. I think you need to find out what is the subset of SysML which is most useful in your work, and then you should really focus on learning this subset. But this subset also needs to be learned in context of some methodology, applying some methodology. So SysML provides 9 diagrams which are typically classified as structural diagrams, behavioral diagrams, parametric diagrams, and requirement diagrams. But the modeling language is just a language. It must be combined with a methodology to be useful, and you need to have some approach how you develop those models, and later how you use them, so that this modeling work will be really useful. For example, you can start with the system context definition. Just we're using a sample, a typical educational sample, which we established to Magic. So this is a coffee machine in the airport, and then you can exchange certain information items or maybe physical items with external participants in the system context. And then you can also establish some requirements, which is also part of SysML, so you can produce requirements tables, or maybe also later requirements diagrams to capture some requirements about that system, which concept is kind of visualized in a system context diagram here. Then you can do some use case analysis. You can say, okay, I would like to understand what are the typical roles which will be using the system, and what are the main use cases, the main ways how we can get some business value out of using that system. So you start identifying initial actors and maybe secondary actors, like in this case, passenger in the airport would like to get coffee, and maintainer is a specific role which is responsible for maintaining the coffee machine. And then you can take one of the use cases and say, okay, I would like to build an activity diagram, maybe to understand the workflow, how the coffee machine is being used for getting a cup of coffee. And then you would try to understand, taking into account the context of the system, with what external participants the coffee machine is interacting. In this case, this is passenger and bank network, let's say, and the passenger is requesting coffee, and then he has to pay. So the payment is handled by bank network, and then the coffee machine, if everything goes okay, then it is responsible for brewing coffee and dispensing coffee cup to the passenger. So we do some analysis of how this use case is performed, and then you try to establish a black box view of the system, which is typically called a system specification. And there are structural and behavioral aspects related to that. So you would maybe do some black box specification. You know, what are the ports to the system? What are the integration points? What are the interface blocks? What kind of information you provide as incoming and outgoing here. But this is just a structural contract. It's very important. People typically use certain documents, like, for example, interface control documents, to list all those interfaces and to describe them in more detail. But this is just a structural view, and you also need to understand the behavior of that system. So in that case, you would do maybe some behavioral modeling, like state machine, which is showed in this diagram, and which is visualizing the life cycle of a coffee machine and how it reacts to certain triggers. Then you would also maybe be willing to analyze some parameters of the system and how they are related. Like, for example, what is the threshold of the remaining supplies, so that we should mark the system as needing servicing, and we should inform the maintainer that he should refill supplies. So these are structural, behavioral, and parametric diagrams which are used to satisfy the requirements which were defined in the diagrams before. But from this, maybe we could say, okay, we still think the system is too complex for us to understand and to maintain, so let's try to decompose it. So then we do system design, and we look at the system as a white box, and we maybe try to compose the system into parts, looking at the functions that it needs to perform. So maybe we recognize that there is some functions of handling the payments, of selling the coffee, allowing the passenger to choose which particular kind you want. There is a specific function to brew the coffee, one of the main functions of the system. And then you also have to dispense it, right? So we identified 4 main functions, and we try to decompose the system into those 4 internal parts. And we can also apply some behavioral diagrams like sequence diagrams, trying to understand how particular sub-functions of the system are being handled by interaction of between those parts. So you would do this, and of course, one of the most important things that the model allows to keep these things in sync, reuse the same elements, and also establish relationships that provide traces between the elements, which is, by the way, very, very difficult to do in models and spreadsheets and tools like that. And it's difficult to do, and it's almost impossible to maintain in that source. So, for example, you would like to see which particular functional requirements are traced to which particular function. So there are certain functions which we identified by designing a state machine for the coffee machine, and then we trace them to specific functional requirements that are specified by the stakeholders. And we can also allocate, do different tracing, for example, allocating functions to the subsystems which are identified in the previous diagram, which provide the classifier information for the parts of the system. There could be also many different views, but we can. Okay, I think we have some sound issues. Let me check if we can. Let me check with Aiste if she can hear me. Aiste, can you hear me?
Yeah.
Okay, so let's try to continue. Sorry for the connection. It sometimes doesn't breaks up the dialogue. So if we find some quality issues with the voice, we maybe will try to record this presentation and publish it on the website. Record it in a silent mode without webinar. So let's continue. So basically, we have traces between elements, and they can be different types of elements which are being traced. You just cannot maintain all of those traces, so you have to really choose which elements and which relationships you want to analyze and which traces you want to maintain. But maintaining them in model is way more easy than maintaining them in documents. I will later give some demonstration of how we do that in our tools. But all these diagrams which I've shown now, following a certain approach of how to develop them, they create a lot of model elements, and then you need really a framework and a more detailed method, like how to structure the model, what views you want to build, and which artifacts to deliver to certain roles. In one sequence, we do those diagrams. Some organizations prefer to start with system context analysis. Some organizations prefer to start with requirements. There are different levels of requirements and so on. So every company deals with the same issues differently. So some of them try to use some frameworks which are known in practice. For example, defense architecture frameworks like DODAF, NATO architectural framework, or Ministry of Defense architectural framework. And there are some others which are maybe lighter, like model-based system engineering methods like OSEM or Harmony, SysMod, functional architecture specification, and so on. So, but those methods really they lack on really detailed guidance. So they provide you some framework, but from our experience, we see that that's probably not enough. So if people transition from documents to models, they really have a number of questions which are not easily answered. So what we try to do at NoMagic, we currently spent more than 10 years working with various organizations, both in software and systems engineering, and we try to capture the best practices of how to organize the model, and we are trying to propose a framework which is called Magic Grid, which tries to address modeling needs at various levels. It is just a framework again, but I think it's a bit more detailed than you can find in other frameworks available right now. But I will not focus on this framework for this session. There was a separate webinar, which I believe is recorded, about the architectural framework, and you can find this on the webinars website at NoMagic. And probably later we will also be doing more detailed seminars on specific parts of this framework. So we're trying to propose a framework which is a consolidated set of best practices, how various organizations do that. But keep in mind, this has to be, of course, adjusted, tailored to your context. So it might be that you reuse some ideas, but you still come up with your custom framework to support your current practice. But one way or another, you will always end up using some architecture framework, whether you want or don't. Otherwise, without architecture framework, it is really impossible to maintain the model, and it's impossible to find information. So this is methodology, and architectural framework is something which is really a must if you want to really get value from model-based system engineering. And last but not least, yes, you also need a tool. So you need some modeling platform, and we propose MagicDraw as a modeling platform. There are different modeling, so some of you maybe use or have heard about Cameo Systems Modeler, which is based on MagicDraw platform. But this is a modeling platform which is produced by NoMagic, and it's one of the most popular UML and SysML modeling environments in the market. It's available for 18 years now, and it is installed and used in more than 90 countries. Even in countries like Vatican, we have users. And it is widely regarded as the most standard compliant tool, and it is designed for customizations to customer needs. So you can customize it, you can remove all the SysML elements and the diagram elements which you don't need in your approach. You can produce report templates which enable you to generate documents from models which are exactly those which you used before or you want to use in the future. And you can find more information in the website. I will later demonstrate some of the capabilities which enable easier transition from documents to model-based. But I would like to maybe emphasize a couple of capabilities which are very, very important for supporting the migration from models to documents. So recently, I believe even documents move to more collaborative environments. You find people using Google Documents or Microsoft 360 web-based solutions to basically collaborate and together contribute some content to the documents. So you should be able to do the same thing in modeling, and Magic provides an environment, Magic Teamwork Server, for having a centralized repository for being able to access models for multiple users to work simultaneously, prevent conflicts, manage configuration, etc. However, if we want to realize the value of modeling and models, we have to understand that it's not only those people who are working in modeling environment really want to use the information. We actually are creating the models, and these are the modelers who are doing this work. But it's very typical that in an organization you would have a much smaller amount of people who are contributing to the model contents, and a much larger amount of people who want to read this information. For example, in some organizations which model the business processes that they have to follow in certain years, like for example developing a new product, you can find that maybe only 10 or 20 people are contributing to evolving the models, but then will be hundreds or maybe sometimes thousands reading this information and providing some feedback to the modeling team. So we okay, let me try to restart the audio. I think there are some people are complaining that this is not working well. Okay, let's see if this is better now. Aiste, can you hear me? Yeah, Aiste can hear me. So let's try to continue. Basically, if you want to get use of models, then you need to create the models which follow some principles, so that they are created in a uniform way, so that you can really use them and you can find the information where you need, etc. And then you also need to govern the models so that you can baseline certain versions and then rely on some stable version, and then also allow other people to work on the evolving versions. So there is a lot to say about models quality, about version management, baselining models, branching them, comparing changes, etc. This is not the focus of this webinar in particular, but I would like to say that this is typically much easier to govern the information in modeling environment than if you put it to documents. And last but not least, we need the center of excellence. Some organizations call it center of excellence, some organizations call it center of competence. But these are basically a group of people who coach other people and who know more than the others maybe about modeling, and they would teach others how to do it in a proper way, how to read the models, and how to get the value of that. So I believe that only in combining those three aspects you can get high value from modeling and models. And you know, in order to make these models really used, what you have to do, you must make them accessible without specialized tools. And many people would still like to get documents. Many people would still like to get documents, which is the form they are used to. So you can provide multiple points of view, and you can provide multiple forms. Can provide those views in multiple forms. For example, we see very often that organizations publish model in HTML in order to browse for information, and then they would also maybe publish this in Word documents to give to some agencies, or for example to review and then add comments and approve, etc. And we have a capability which is called Reports Wizard. So through reporting capability, you can build some report templates, and you can use those report templates to produce outputs, which are documents, spreadsheets, code, browsable information, database, which are generated from the model. So it may look something like that. You can check out webreports.nomagic.com for some examples which show how published information look like, and how to find this information. But recently we also recognized that just publishing information is maybe not enough, because you need to collaborate and you need to get some feedback. So we also introduced a new product which is called Cameo Collaborator. Again, there is a separate session recorded about this capability, but you are not only able to publish, but you are also able to assign to basically gather comments and annotate diagrams and provide specific suggestions to the authors of the model. So this adds a collaboration capabilities on the top of published models. This has been found very, very useful, and many organizations are looking forward into taking this new product into use. But I would like to say that transition is not easy. So basically, we have current practices, which maybe sometimes might look like that, but people are used to that, and then they know how to make things work. Even like this guy in the picture here can make actually really good things with these simple tools. Some things might not be very easy. Some things might require a lot of work and a lot of rework sometimes, but he knows how to use those tools. And if you're proposing something different, a new set of tools, which is maybe much more powerful, but if you try to transition too fast, then you're basically giving powerful tools to the person who doesn't know how to use them, and he can easily do more harm than value for organization. So you have to really adopt model-based system engineering and move from documents to models in a very well defined transition. So we typically, at Magic, we typically say that there are those 4 phases that you need to gain understanding of what is the potential value and how it could be beneficial. Then you need to build proof of concept, a small model which demonstrates how it's going to be, the concepts going to be used in your context. And then you have to run 1 or more pilot projects before you really try to institutionalize it as a new practice. Maybe what I can share in advance, let me do it this way, that I will share some lessons, and then I will maybe demonstrate some of the tool capabilities which enable an easier transition from models to documents. So we worked with a lot of organizations in trying to move from documents to model-based practices, and I think we learned the following top 10 lessons. The first lesson is that without leadership, organizations don't change. It is not easy to change the practices. People are used to doing work in their in particular way, and if you don't have a strong leader which wants to change it, things don't change. People come back to the previous practices. Then you need to establish internal center of competence so that you can really coach other people and help to adopt new practices. Just establishing center of competence is not enough. You have to dedicate time for coaching and learning. If people are trying to work in the project, and if this project is planned according to the previous practices, which maybe do not allow for time for trying to adopt new model-based practices in the initial phases of the project, which, by the way, typically requires a bit more work in initial phases when you try to understand requirements and develop a consistent architecture. Then it is unlikely that people will be able to adopt those new practices. They will be running after this target, which is a milestone in the project, and they will be coming back to their previous practices to do it fast. Then SysML is not enough. Methodology is a critical factor for success. Too many organizations have to try to do this kind of thing, like learning SysML by the book or maybe by some trainings without understanding their context, and then just saying it to a large amount of people, let's try to use it. It doesn't work. You need to really understand very well how you will instill these new practices in your current engineering practices. And you need to really do it in an evolutionary way. Then you need to start with a small team and achieve quick wins. Don't try to change everything in an organization with model-based system engineering. You have to start with a small project, maybe address only certain area like system architecture, maybe, and how it is combined with maybe requirements or maybe with test cases. So you choose some area to improve, and then you try to achieve quick wins. Then you clearly choose which problems you want to solve, which I think I just mentioned, that you choose the area where you really have problems, and the area where you can demonstrate those quick wins easily. So go for low-hanging bananas, but really know where those bananas are. So you have to solve existing problem. Don't try to solve the problem which does not exist. Then I think you need to enable model-based cross-functional collaboration. So publishing models and getting feedback is very, very important. Then you need to investigate how exchange data between modeling and other tools, including documents and spreadsheets. I will show a bit on how we enable that. But when you do this, choose only one tool as a master source for certain information. Don't try to manage requirements both in Magic Draw and in Doors and maybe in some Word documents. So you have to be very clear what is the master source for certain kind of information. You can import proxies of requirements maybe in the Magic Draw model and trace architecture elements to that. In that case, master source for architecture and for traces to requirement would be Magic Draw, but the master source for the requirements would be Doors. And then last but not least, you need to communicate so that everybody understands why we are going this way and what we're trying to achieve and what are the next steps and why this is beneficial to the organization. Changes, especially in large engineering organizations, are not easy. So what we propose really is evolutionary approach, and we propose that you should think big, you should understand the potential benefits of model-based system engineering, but you need to start small and you need to evolve towards the goal. So at this point, I would like to switch. To spending maybe 10 minutes or so on demonstrating some capabilities which we have in the tool to enable easier transition from models to from documents to models and back really. Then we can handle some of the questions and answer the remaining questions later on. So I switched now to the modeling environment, and in the modeling environment, what we can do, we can actually have things like this, for example. So this is a table of requirements, which is a standard SysML table. But let's say that people are currently doing that in tools like Excel, right? Then what what you do, you would start to maybe create certain people would write requirements like that. For example, they would say sugar level in coffee. This is, let's say, this is a name for the requirement, and then they would put this particular requirement. They would say the system shall allow user to select how much sugar he wants in coffee, right? Or he would they would also say, okay, let's say that this is yeah, I made a typo here, so let me fix that. And they could also say that okay, the cash payment. The system shall allow user to pay in cash, right? So you would have people putting requirements like that in Excel sheets, and at a certain point you want to take them into model. And recently, what we really enable is you can really kind of select information in Excel sheet, and you can just copy and paste it into tools like Magic Draw. So I would just copy this text from the Excel, and I would go into maybe my model, and I would create a package maybe for these requirements, and I would say this is stakeholder needs, stakeholder needs, and let's create maybe a new table. Let's say this is a requirements table, and at this point, what I will do, I will just hide the ID because I have not specified IDs in my, and I will just use paste functionality. And in this case, I will say, okay, these are maybe these are functional requirements which I have here, right? So you see that the information which was in Excel, which was transferred to the modeling environment, and then you can see some statistics that 2 elements are created, 0 updated, and 0 failed. In fact, if you continue gathering those requirements in Excel sheet, you can later do another copy paste, and if you change something, like in this case, I think if I just say cash and bank card, I could try to copy paste and it would update a couple of requirements. You see that the text in cash and bank card is being updated. So at least for some temporary phases where you try to switch this practice and you want to allow people to really do this work in the documents the way they used to do, and only at a certain level when you say, okay, it is very important for us to understand what are the relationships for these requirements, how they relate to the architecture. Then what you do is say, the most important thing for me to do is to understand if I don't have any gaps between architecture and requirements. And then what you would do, you would really try to create some analysis. I have some analysis sheets here, so maybe I have to know in my architecture framework where I put this analysis, but I would make a diagram which is maybe a matrix, and I will just create this matrix really quickly. So I would do the dependency matrix, and I would say I would like to see how requirements, stakeholder needs are linked to functions. What I do then, I just take a package where I have stakeholder needs, and I will put them to the scope of role. So I just drag and drop this place, this package in the model to the dependency matrix, and then I say I would like to take a functional requirement. So I just drag an example here. So it says functional requirement here, and I'll say actually on the columns I would like to have system functions, right? So I go to the system, and maybe in my case I actually have a system defined here in a state machine. So my functions are actually identified in context of a state machine, like for example here. So what I do, I just take one of the functions, and then I drag it to the column element type, and then I say I use my coffee machine, which is my system, as a scope for identifying, for finding the functions identified there. And then I would say, okay, I want to use maybe just a trace relationship. I could maybe use also satisfy or some other things, but let's say just a trace relationship at this point to trace those requirements to use cases. To functions. So then what I do is I have this this table here. It's now showing the places where those elements are located. So maybe I will just configure the dependency matrix to say that I just want a list of things here. So I have a list of functions, and then a list of requirements. In this case, just 2 examples, but typically would have many more of requirements, of course. And then I would say, okay, actually, this cash payment is relevant to selling coffee. So I will just select that this is row to column to row maybe. So what I would do, I would say sell coffee should actually allow user to specify sugar level in coffee, and it should also allow you to do payment in cash. And then when you, the request supplies refill and initialize coffee machine, maybe they are not related to these requirements. Dispensing coffee copy is also not related, but the brew coffee probably should take into account sugar level in coffee. Cash payment is not something which is interesting for the brew coffee function. So you would do this kind of mapping, and then you would see that there are maybe some functions which are not covered by requirements, or maybe there are some requirements which are not captured in any of the identified functions, and then you need then you know that you need to add more functions. So you would focus on modeling environment to establish those traces, and you would make sure that the architectural framework that you use it then allowed you to identify all the capabilities or all the subsystems or some other things which have a good coverage of requirements which are managed and maintained in different tools, like for example Excel sheet in my example. And yes, you can also go back. You can also click on export, for example, and then I could say I would like. In this case, this can export, in fact, a matrix of this mapping, right? So I can say, please export it here, and then if I go to this place where I just generated the document, which would be I think this package here. Then I have I think I have this comma separated value sheet, which is this thing, and then it would yeah, it's coming now in comma separated values, which I think need to be I think it needs to be just opened from here, and then it would look better. But there are some places where really tools like Excel work really strange. I think if I just doesn't allow me to do that. Okay, it doesn't matter. I mean, just you would open and read it in a different format. But if I take, for example, this needs here, then you would be able to maybe export it again, and then I would say just use Excel workbook here. So you would just save it, and now I think I would be able to open that without any issues. So I think comma separated values you probably need to import with this version of Excel, but this table would be shown in picture like that. But this is a very straightforward example which works out of the box. In many cases, you actually need a special way how you want to export this information. I'll show you just one example, and then we can come to the questions about from you. So I will switch to a different model which I have opened, and we worked with one software organization which was moving from document-based to model-based practices, and they had information which looked like this in the model. So you would maybe have a data structure here, and then it is described, and then each actually attribute or each value property in the system, let's say, would be described. And they were willing to give a document to developers who would be developing the system, or maybe a document to the third-party partner, just a partner who would be relying on those data structures to get some information. And their current way to exchange this information is really through documents. And that's also the way to review it. So what we did for them, we actually created a very simple report template, which is custom for their needs. This is, by the way, just a prototype which we did for them. They later maintain it, but we put some work into creating a report template, which is really pretty simple template. I was able to do that in a couple of hours, and it would go to this model. So let us try to generate this report template. I just say which information from the model I take, and then you would say, let's generate data report, data, let's say architecture spec doc X, a specific document out of this. So you generate this, and then it opens a document, and then people can find information there. They can navigate to certain elements, see description. They can also find diagrams, and then they would use their current practices, saying that, okay, I would like to maybe go to review and select things here, and then say I would like to add a comment maybe to this to add a new comment about this structure, and they would give it back to the data modelers to do some changes. We try to work a lot actually in this year, like how to transition easier from documents to model, how you enhance this information in the model, and also how you can do vice versa, how to use model to generate documents which are suited to particular needs in the company. Let me now maybe switch to the questions. Okay, so I think there are some questions, like, for example, does anyone have tried to start without a tool? I'm afraid that the definition of a tool will block the process evolution or limit understanding of model-based system engineering. I think I actually believe that it's impossible to use model-based system engineering without a tool. I think really, if you're doing it without the tool, then you're doing just drawings, and then you cannot really have the consistent information, and you cannot really reuse it and generate different views and maintain it. Yes, you can do some. You can start a little bit on understanding language, and you can do some kind of throwaway modeling. Not really modeling, maybe more drawing some pictures. But I think if you really want to deploy it successfully, you need a tool. But what we would really suggest that you should not take tools like Magic Draw, which are very have a lot of different features, and you should not deploy it out of the box in an organization. Like in Magic Draw, you can really, I can show now, you can go to like perspectives, and you can say, I want to customize it. And then you can go to maybe diagram toolbars, and then you can say modeling element toolbars, for example, and you can say, I would like to go here. This diagram which is open here is just a class diagram, so maybe I can say what I want to use here. I don't want to see many of things, and I just want to maybe just directed association, no generalizations, no pores. This is not important for me, and then you would be able to, okay, the interfaces are not used in data modeling, so this is not something I use. I don't care about aggregations, and then you go here and say, okay, well, maybe actually generalizations, maybe something which is useful, right? So and then you say, I want to hide all other elements. So then what you do is you simply say, that's my view to the system, to the capabilities which are provided by the system, and I just want to simplify it for the users, right? And then instead of many capabilities which are there, you have just a small subset of elements which are available for the users. So really, you should simplify the tool as much as possible for getting started, and only the experts maybe would switch to the kind of full featured node and then see all the capabilities. So there are ways how you can simplify this transition, but without a tool, I don't believe you can really apply model-based system engineering. Okay, then the next question is, what is the strategy for collaboration in tool diverse environment? Do you have OCL capabilities? Yeah, we are working on some OCLC, Open Service Lifecycle the capabilities, and basically, but we also have different partners and different tools which enable you to exchange information between different tools. For example, we have a platform which is called Data Hub, and this used for exchanging information between typically requirement tools like DOS and Magic Draw. Then we also have an open API which can be used for exchanging and integrating things. And yes, Open Services Lifecycle is also on the agenda. In our research and development, we do have some capabilities, maybe not everything what some organizations would need, but we are working in many directions how to integrate different tools. And the other question is it possible to obtain this example? Yeah, sure. We will share all the examples which are shown here, and the slides and the video recording of the session in the websites. You will get information. Just keep subscribed, and we will share that. What is a good example of a US government organization that has successfully run an acquisition program with this approach? Unfortunately, I cannot answer that because my experience, I'm not American, so I cannot work very closely with the US government. companies. I work mostly with commercial organizations. So my experience and best practice are coming more from this. But I think you can search for other presentations which are shared in some conferences, and I think U.S. government is really promoting quite actively promoting this model-based system engineering. We have a lot of customers from defense department and other departments of U.S. government. So I think model-based system engineering is really a big topic on the agenda of. Then there is another question: is there some more information about Magic Grid? Yes, we can provide more information. Just get back to us, and we will give you some papers. There are actually some scheduled presentations. We will also run No Magic World Symposium, which is a conference for modelers, which we annually run. This year it will be on May 22-25, if I remember well, in the United States. And we will be running there some sessions introducing that. Okay, and then there are some other questions which are kind of, I think we will try to answer them after the session because we're running out of time. So I will transfer then the word to Aiste, and Aiste can do the close out of the session.